Assalamualaikum and greetings. My members and I will present about reverse osmosis of wastewater treatment as per chosen by us for this project. Let me do the brief introduction of the members. Firstly, we have me, who is Nur Kamilia binti Sobri. Next, we have Darren Arvin Singh, Maylen Han, Nur Awada binti Nozul, and Aloysius Baxter Victor Jublake. We are all from Group 11. Now let's us proceed. Wastewater treatment is known as the process of removing impurities from wastewater or sewage, and it also can be called as sewage treatment. The wastewater should always be treated before it is being dumped into natural bodies of water such as ocean, estuaries, lakes, and rivers. Wastewater treatment is needed due to the occurrence of water pollution. Water pollution is the release of materials into the subsurface of groundwater or into the lakes, rivers, ocean, and estuaries, in which it will cause the disruption to the beneficial role of the water or its natural role of the ecosystems itself. In wastewater treatment, there are four main ways, which include physical water treatment, chemical treatment, biological water treatment, and sludge treatment. Reverse osmosis is an important method among other methods of physical wastewater treatment. Reverse osmosis is the process of removing contaminants or impurities from unfiltered water through the implementation of pressure forces through a semi-permeable membrane. In reverse osmosis, the water will flow from the concentrated site in which it contains more impurities of the membrane to the site of the less concentrated.
Hello, my name is Melan and I'm going to talk about the problem statement and the objective. The first objective is to study the type of control system used in this reverse osmosis process, to study the challenges faced in this process control, and to study the recommendations that could be applied in the control system used in this process.
Hi, my name is Darren Arvin and I will be explaining on the control system part. The system that will be used is the pressurized recycle reverse osmosis system. This system is an alternative system to replace the original design of the reverse osmosis system. Now, why don't we use the original design? This is because this existing design lacks any kind of automation as all operations are done by hand. A pressurized recycle reverse osmosis system is a system where a control valve is installed to make sure the flow is maintained at the set point. There are three objectives of this control system. The first one is the flow rate is to be controlled such that a minimum residence time of 5 minutes through the adsorbent media is maintained. The second one is to maintain the pressure in the high pressure tank within operating limits. And the third one is flow rate to the membrane must be sufficiently high in order to avoid substantial concentration polarization. Moving on to the steps involved in the system. The first step is raw water is pumped through a wire strainer to remove big particles. The second step is the de-oiled water is then passed through a high pressure pump. Here, the control system takes action. When the permeation rate reduces, the feed salinity rises, which causes the control system to limit the flow through the high pressure pump. This is to keep the pressure from increasing too high. The water then passes through a large high-pressure tank route to the reverse osmosis system membrane, where it mixes with the recycled concentrate from the membrane. And the last step is the reverse osmosis membrane separates the flow into the concentrate and also the permeate streams. The concentrate is usually recycled back to the pressure vessel. Now, moving on to the next section, renewable energy for reverse osmosis. Wind power has been used by many scientists to run a reverse osmosis system. For example, they compared the economics of wind-powered versus diesel-powered reverse osmosis system, and it was found that the wind-powered technique was discovered to be most cost-effective. And this proves that a renewable energy source can be utilized as a power source for a reverse osmosis process. This will help in terms of reducing the use of non-renewable energy sources.
Hello, my name is Aloysius and I'll be focusing on the challenges of reverse osmosis. According to Davenport et al. 2021, the development of RO presents a myriad of challenges. When the operation is conducted at ultra-high pressures, the RO system is prone to system leakage, whilst the salt solution easily causes metal corrosion. Another typical problem with reverse osmosis system is membrane fouling and scaling, which occurs when materials accumulate on the membrane and slows down the flow of water. Besides that, the RO system often experiences loss of normalized permeate flow and increase in normalized salt passage. This occurrence is often due to factors such as faulty gasket interconnectors, membrane surface abrasion, and membrane layer oxidation, which then inherently affects the water quality. Another challenge is cost and sustainability. The complex nature of a very big SWRO plant in a larger system, which relates to the amount of area demanded and the number of components, is extremely costly and increases the carbon footprint. This, coupled with a huge water consumption, may be detrimental to our water reserves, and it is definitely not sustainable for our environment.
Hello, my name is Nur Awada, and now I will talk on the recommendation of the reverse osmosis system in the point of view of process control system, instrumentation, and the operating system. For the process control system, HMI and PLC can be installed as a safety control system to prevent leakage or failure or any issues in the system which require immediate action by the operator. It will monitor input and output state continuously, and it is equipped with a safety alarms to notify or alert the operator when there is any issue in the system. Thus, it will increase the safety rate of the entire system. Next, for the instrumentation, the installation of flow transducer will allow accurate flow rate and pressure reading, which is critical to monitor the performance of the membrane elements. And the allocation of the pressure transducer should not be located at downstream of the throttle valve directly to prevent aspiration effect, which might affect the accuracy of the pressure readings. Modifying the system in this aspect will increase the system accuracy. And lastly, for the operating system, it was found that the common problem in a reverse osmosis system is membrane fouling. Membrane fouling is a condition where the suspended particles from the feed water deposit on the surface of the membrane and block the incoming water from passing through the membrane. Hence, it will affect overall recovery rate of the reverse osmosis system. The suggested solution is feed pretreatment. Since membrane fouling is heavily influenced by the quality of feed water, treating the feed water will allow the incoming water to pass through the membrane smoothly. This will reduce the work to be done by the pump and the energy consumption, which will consequently reduce the cost to operate the system.
In conclusions, our group had been successfully analyzed the wastewater treatment for reverse osmosis process in this report. Hence, all the objectives had been achieved. Overall, this project helped us to expose to the importance of the wastewater treatment. That is all from us. Thank you.